Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to part 3 for our auto runner tutorial series, our penguin sledding tutorial series. In this video, we're going to be focusing on our player character to get their movement matching the movement in the actual game. There are going to be a few different aspects to this movement. We're going to have jumping, what I'm going to call unjumping, which you'll see what that is. We're going to have acceleration and hitting some sort of max speed. We're going to have friction in some places. And we're going to divide this up based on whether we're on the ground and whether we're not on the ground. That's going to be an important aspect of how we handle the logic. So let's open up our player scene right here. Click on the script so we can come into our player character. And the very first thing we're going to do is actually, oh, hold on just a minute. Sorry about that. I got a notification. Hopefully it wasn't too loud. But the very first thing we're going to do is take our is on floor logic and we're going to pull it into its own if statement and add an else statement like this. And we're going to have to change this into an if here. We're going to have to tab this in. If is on floor. If it's getting mad at me for something. Mix use of tabs and spaces for indentation. Really? Oh, I do have a space there. It's right. I did have an extra space there. Okay, Godot knows what it's talking about. So we're going to separate into two places, when we're on the floor and when we're not on the floor, and we're going to handle logic differently based on those two cases. We'll start with gravity. Up here at the top, I'm going to create a new variable, and it's going to be an export variable. Now, making an export variable just allows you to alter the value of that variable in the editor, and this can make it more convenient when you're prototyping and just experimenting with different values, or if you have a team and you have programmers and then you have designers and they're separate from each other, you can allow the programmers to export, or I guess open up aspects of the game to the designers without the designers having to manipulate the actual code. So we're going to call this var up gravity. For now, we'll set it to 0. And we'll have a down gravity. Set that equal to 0 as well. So I have two different gravity values here, and the reason is because with platformers, it can feel nice to have the character be a little bit floatier on the way up to give more anticipation and more time to the player, and then a little bit faster on the way down. And so we're going to set our up gravity to 250 and our down gravity to 500. That makes it so that we can rise a little bit slower but fall a little bit faster. Now that we've done that, we're going to actually apply the gravity. Now, we'd already applied gravity right here. This is where applying gravity, right? But we didn't name any of it. So let's actually remove this, but I'm going to do Control X so that I can copy that. And then I'm going to paste it inside of is on floor here. Or not is on floor, sorry. The else, so if we're not on the floor. Just like this. And how can we tell whether we're going up or down? Well, we can check our velocity.y. Now up we know is negative and down is positive. So if our velocity.y is less than 0, then we know that we're moving up. And if it's greater than 0, we know we're moving down. So we'll just say if velocity.y is greater than 0, then we'll apply, that means we're going down, right? If it's greater than 0, that means it's positive, which means we're going down. So we'll do down gravity. And then I'm going to do else, paste this, and just replace this with up gravity. And there we go. Now we're applying a different gravity amount based on whether we're going up or down. Now I know this isn't realistic. This isn't how the real world works, but games oftentimes aren't designed to be realistic. They're designed to feel good. And so this is what we're going to be doing here. And I think this feels better. Let's give this a quick test, make sure that it is working. And you can see our jump force is now way too much. So let's work on our jump next. So we're going to, and before we move on, if you click on the player node here, you can see that our up gravity and down gravity are both over here in these properties. So by the end of this video, if you choose to, you can, you'll be able to manipulate these different values to get something that feels good to you. I'm going to show you the values that I used for the original Game Jam game, but feel free to manipulate these values as you see fit. So let's create a new export variable. We're going to call this our jump force, like this. And we're going to set this to 180. So now we only want to be able to jump when we're on the ground, and we've already set that up here. So if is action just pressed UI up, velocity minus equals 350, we're going to change this to jump force, like this, instead of 350. Now let's give that a try. And that's much better. Okay. Now let's look at unjumping. So I talked about unjumping. So let me show you what unjumping looks like. We're going to actually have an unjump force. So unjump force, and I'm going to set it equal to 25. So what is unjumping? In the actual game, when you press the jump key, your character goes up. But the second you release the jump key, they actually start moving down. And that unjumping is what allows the game to have kind of like a almost like a Flappy Bird feel to it, where your character goes up and down really quickly. And it's just kind of a natural I guess, consequence of the prototyping that I did and what felt good. So we can only unjump if we're already in the air. So if is on floor, we don't want to be inside of this logic. We want this to be inside of the else where we're in the air. We're going to say if input dot is action just released UI up. Then we're going to say velocity dot y equals unjump force, just like that. And it's actually going to go down, so we don't want to do negative. So you can see with our jump force, we set it to 180, but we subtracted from it because we're going up. Now, technically, you could make this negative 180 and then just not have a negative here. So that's kind of up to you. I prefer to have the negative here, but it is up to you. So let's run this and see how this feels. So now, if we release, we should immediately come back down. Yep, there we go. Now I also want to change our character sprite to reflect the sledding animation. So we'll come into the frame and just set it to that for now. There we go. And that makes it feel a little bit more natural. And we have our unjump added to the game already. So we have jump and unjump, and we have our gravity. Now let's get the acceleration and the maximum speed to match. Okay, currently we're accelerating right here, and we're clamping our maximum velocity using the min function, like this. What we're going to do instead is we're going to create an acceleration that checks to see if our value is less than the maximum value, and then we're going to move toward that maximum if it is less than it. This will allow us to actually sometimes go faster than the maximum value, but our default acceleration won't ever make us go faster. And that's kind of important because this game is a speedrunning game. So we'll say, first we need to create some variables. Let's come up here at the top. We're going to create an export variable called acceleration. And we're going to set this value to 150. and we're going to create an export variable called max speed. And we're going to set this to 290. Okay, so there we go. Those are now appearing over here on our player's information. We can say if velocity dot x is less than max speed, velocity dot x equals move toward velocity dot x. Then, so the move toward function is a function that allows you to approach a value but not go past it. And that's what's nice about it. So we're going to move toward, and the first value we pass in is going to be the value we want to change. Then we're going to pass in the 2, which is the value that we're approaching, which in this case is going to be our max speed. And then you want to pass in the delta, which there's 2 different deltas here. There's this delta, which represents the time that the last frame took. And there's this delta down here that we're supposed to pass in, which actually represents the amount that we want to move as we're moving toward this 2 value, the change in position, essentially. That's what delta means here. So it can be confusing because it means 2 different things. So we're going to say, okay, how much do we want to move toward? That's going to be our acceleration, but we also need our acceleration to be multiplied by the delta, as in the amount of time, because this is an acceleration value. Now, I maybe skimmed over this in the previous video a little bit, but move and slide automatically applies delta to our actual velocity value. So we never have to multiply our max speed or this actual velocity by delta, because move and slide does that for us automatically. But if we do have it, so that would be our velocity is our change in position over time, right? And move and slide automatically multiplies the velocity by delta. However, gravity, acceleration, and friction, I guess, they all represent our change in velocity over time. And so we do have to multiply all of those by delta. So keep that in mind. Okay. Now, this should accelerate us toward this max speed, but only if we're less than the max speed. And the reason we want to do that is because if we just move toward this max speed, then potentially if we're already past it, if we're already moving faster, it would actually slow us down to meet that max speed. It would become a friction in that sense. And we don't want it to do that, because we're going to manually apply a friction if we're going a certain speed, and we don't want to use our acceleration. We want to use a friction value. Let's see if this works though. It does work. We do accelerate up to that max speed. So let's add the last thing here, which is going to be our friction values. Now we're going to have, in the same way, I'm going to put them up right about here. In the same way that we had an up gravity and a down gravity, we're going to have 2 different frictions. We're going to have a normal friction, and this is going to be set to 200. And then we're going to have an air friction, which is the friction amount that is applied while we're in the air. And they're going to be different from each other. The air friction is going to be 60, so it's going to slow us down less, right? There'll be more friction while we're on the ground. Export var, oops, I forgot to put air friction. There we go. So now that we have our velocity, we increase our speed when it's less than the maximum speed. We're just going to add an else here. This is where we're going to apply the friction that decreases our speed, our velocity, when we're essentially equal to or greater. We should put an equal sign here, I guess. Equal, less than or equal to max speed. So if we're greater than our max speed, we're going to apply a friction. We can do this with velocity.x equals move toward, no, not move and slide. Move Come on. Move toward velocity.x, max speed, and this time we're going to do friction times delta. There we go. If we do end up going faster than our maximum speed, which there will be cases that we're doing that, if our penguin is going down a slope or something like that, we might start to have some more speed. Then it's going to apply this friction and bring us back down to our maximum speed. So I also realized that I forgot to take this out. So our test didn't work at all. You probably noticed that. Now we're going to move our acceleration here into our if is on floor, because we only want this logic to happen while we're on the floor. And we'll need to make sure that our tabs are correctly set up. Okay, now let's see how this fills. Okay, you can see we start out pretty slow and then we start to build up some momentum. It starts to get a little bit faster. Okay, now we're going to apply our air friction. Now our air friction is going to be slightly different from the actual friction in the sense that this friction up here only reduces our speed down to the maximum speed, but our air friction, we're going to allow it to take our character's speed all the way to 0. So if we're in the air, so right here, we're going to copy our applying friction here, and we're going to bring it to 0, and we're going to do air friction as the amount. Now when we're in the air, our velocity.x will move towards 0 at our air friction rate, just like that. And so now, essentially, the longer our character is in the air, you can actually get stuck on walls now, which is part of how the game works. When our character's in the air, they actually start to slow down. So this incentivizes the player to keep the penguin on the ground. There we go. Now it feels a little weird right now. There's a lot that we need to add in to make it feel more like the actual game, but those are the different mechanics of the movement. Now, our character is always moving to the right, but our camera is situated exactly centered on the player. So we're actually going to change that. We're going to click on our camera node here, and we're going to set the X offset to -64, or let's do +64, I got the wrong way. That's going to allow the penguin to see farther ahead a little bit. And we're also going to move some of these out just a little bit. And maybe add some more stuff in here. Let's reduce the height on this. Kind of high. And we'll make this a 2 slope that goes down like that. And we'll actually stick our player on the ground over here. And maybe I'll make this a 2 slope up like that. Just reposition some of those things a little bit. There we go. It's starting to feel a little bit more like the actual game now. Just repositioning those things, getting them feeling a little bit better. Now there's actually one last mechanic that the game has that's kind of a hidden mechanic, but we're going to add it in. And what it is that the character's speed increases just a little bit every time they land. And this is part of what allows you to gain a little bit extra speed than what you're supposed to just by moving on the ground. So we're going to add this mechanic in. So the first thing we need to ask ourselves is, how can we determine whether or not we've landed? And the answer to this question, you can do it in a couple different ways, but we're actually going to do it using the character's y velocity. If their y velocity was above a certain threshold, above a certain threshold, and now is equal to 0, then we're going to assume that they landed. And we'll do this right here in before move and slide. We can get our previous velocity. So var previous velocity equals velocity. And then after we move, we can use that previous, because what will happen is this move and slide function may alter our velocity based on whether we collide with something. So now we can compare the velocity before our character was moved and the velocity after the character was moved. So order here really matters. You have to have this before move and slide. The order here matters. Order matters a lot in programming. Keep that in mind. If you change the order of something, it might change the outcome. Just like in math, order of operations matters. In programming, order of operations matters. So what we can say is if velocity is equal to velocity.y is equal to 0 and previous velocity dot y is greater than 5. Now I know this is a magic number, but I wanted to make sure that the character had been moving down more than just a tiny little bit. And so I picked that number arbitrarily. It is a magic number that is just exists in the code. Remember, I made this in a game jam, so some of the code, I'm actually cleaning up the code because the actual code is a big mess as I was prototyping. Okay, so if the velocity.y is equal to 0 and the previous velocity.y was greater than 5, then we can assume we've landed. And what we're going to do is we're going to say velocity.x is equal to jump force times 1.5. And so we're going to take our jump force, our unjump force, I apologize. And we're not doing equals to, we're actually adding plus equals to. So unjump force times 1.5. Okay, and that should allow us to increase our speed every single time we land on the ground a little bit. And build up a little extra speed. Now I'm realizing now that we need to multiply this by delta, but that would mean that I also have to multiply this number. So I might actually create like a landing acceleration is what I'd call it, in order to make sure we're correctly multiplying by delta. So landing acceleration, and I'm going to set this equal to, what's 60 times 1.5? Here's a cool trick, 60 times 1.5, highlight this, right click, and do evaluate, and it will automatically do the math for me, which I probably could have figured that out, but that is a cool trick. Godot allows you to evaluate an expression, and there's a hotkey for it too, if you want to. So we'll do landing acceleration times delta. And that should be close to what it was. I'm not sure that that's actually working. This equals, let's print the velocity. This is what happens when you change code on the fly. Velocity.x. Let's see what value we're getting here. Yeah, we got stuck. Okay, 217 and the max speed is 290. We're never actually able to accelerate that much, so it's not actually working. This must need to be higher than what I have it at. I'm going to double it. And so now I know that $232. Yeah, it's actually slowing me down. I can't actually exceed. I think when I'm jumping, it's actually slowing me down a little bit. Okay, I know what I did wrong. I'm supposed to take the unjump force, which is 25, and I'm supposed to multiply that by 60. Because if we're going to multiply the unjump when creating the landing acceleration. Because if we're going to multiply the landing acceleration by delta, this is generally going to be 1/60th of a second inside of the physics process. And so that's why we need to multiply it by 60. but I multiplied it by 1.5, which we also want to multiply it by 1.5. And that should give me the previous value that I had, but accounting for delta. So my math was just wrong. Let's try this. We'll evaluate section. That's a very high landing acceleration. But I think that's the correct one. Yeah, that feels correct to me. Okay, there we go. So there you have it. That's the landing acceleration right there. And you can see we were able to exceed the maximum speed of 290 by using landing in order to build up a little bit of speed. So now we can remove this print velocity here. That's going to be it for this video. It was an extra long one, but we got our character controller working. In the next video, I'm going to be adding in the animations for our character, or at least some basic animations, which is mainly going to be procedural. And then I'm going to be adding in the colliding with walls, resetting the character back to the beginning of the level as well. If you want to try messing around with some stuff, I'd recommend messing around with these values right here. If you change any of them and you want to set them back to their default value, you can just press this right here. That sets it back to the default value. And then I would also recommend creating a level that's a little bit interesting to maneuver in, that forces your character to avoid maybe some ceilings and test the toy, feel how it feels to move this character around inside of a level that you design. So that's it for this video. Thank you so much for watching. If you liked it, please subscribe, like the video, comment down below. If you're interested in my other Godot content, I have a bundle right now that you can check out on my website that has 3 full courses and my book. So I recommend checking that out, and I will talk to you all in the next video.